In this section, we learned, okay, so previously we learned how to graph sine and cosine, and then we're going to move on to the next one, to the tangent. Okay, so today we're going to talk about how to graph a tangent. Okay, so here's what we start with. Remember, tangent was sine over cosine. Okay, now whenever you have a function with a variable in the denominator, you run into some issues because when the denominator is 0, the function will have asymptotes. It'll be undefined. Yeah.
Maddie just texted me to tell you that she got kicked out.
I just noticed she got kicked out. Yeah, okay. Thankfully, I'm doing a recording, and then when she comes back, she'll join us. Thank you. So, we say tangent is undefined at all points where cosine of x is equal to 0. At those points, the graph of tangent of x has vertical asymptotes. Okay? All right. So here is how the tangent and the cotangent functions look. We're not going to worry too much about the cotangent function right now, but what we're going to worry about is the tangent function. So take a look at what the tangent function looks like. The tangent function has vertical asymptotes at the beginning and end of each cycle. So take a look at how the tangent graph looks. Do you see how it's very, very different from the waviness of the sine and cosine? Very, very different. But what is the same is that cyclical repetition, right? It repeats in cycles. And when you look here, one cycle of the tangent, or each cycle of the tangent, is each one of those branches. If we take that one that I've highlighted in green, you see how at the very beginning and at the very end of that one cycle, there are vertical asymptotes. That is the characteristic of a tangent graph. If I were to ask you to draw a bunny rabbit, okay, you could be the best artist or the worst artist like me. What's the first thing you know you should put on that to make it look like a bunny rabbit? Does that mean the ears? You got to give it the ears. Otherwise, it does not look like a bunny rabbit. Well, for the tangent, it's the asymptotes. Okay? All right. The period of the tangent is pi. Remember, for the sine and cosine, it was 2 pi. For the tangent, it's only pi. And what's also important is that the graph increases to the right. So if you look at that one branch of the tangent function, it goes up on the right and down on the left. So that's what you need to know. Sam?
What exactly is an asymptote?
Oh, sorry. I'm sorry. I should have specified that. An asymptote is a line, it's an imaginary line that the graph comes very, very close to but never touches. So if you see here this graph, on the left, it starts going like almost like vertically down like this, and it comes very, very close to that dotted red line, but never really touches it. Okay?
Okay.
All right. So let's come down here. The period of the tangent function we said is pi, so it takes a length of pi, but the initial cycle, remember for sine and cosine, it starts at 0, goes to 2 pi? For the tangent function, the initial cycle starts at negative pi over 2 and ends at pi over 2. That's what we need to remember. Oh, by the way, I forgot to tell you that at the end of the lesson today, you're going to submit these pages into MyJack, so make sure you're taking notes. I still want us, and we're gonna do fancy stuff with like labels and stuff soon, okay? All right. how do we graph the tangent function then? Remember how for sine and cosine we went 0 less than or equal to blah, 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 2 pi? Similar to that, for the tangent function, it's going to look like this. We're going to go from negative pi over 2 to pi over 2, not 0 to 2 pi. And the inequalities are just less than and not less than or equal to. So it's going to be negative pi over 2 less than, the function, and then less than pi over 2. Okay, so first you do that. Then you figure out what the asymptotes are and you graph them. And then we need to label the 5 critical points again. Same thing. And then we plot. So for the rest of them, why don't we do one and then I'll go through one while we're doing a function. Okay, so here we're going to graph tangent of x. Here's my x-axis. Okay, this is just simple old tangent of x. There isn't anything that's changed here. So the graphing region is negative pi over 2 to x to pi over 2. So I start from negative pi over 2, 1, 2, 3, 4, and I go to pi over 2. Okay? Now, I need to find the other points in here. Okay, so look. Smack in the middle, what's halfway between negative pi over 2 and positive pi over 2? 0. When it's symmetric like that, it's going to be 0. And then to the right, between 0 and pi over 2 is pi over 4. To the left is negative pi over 4. So far, not much has changed. Okay, next, let's do the asymptotes. Asymptote here, asymptote there. Okay. Okay, and we've done the critical points. So now we're going to go to number 4 of this. Plot the center point on the x-axis for the default sign. So the center point, I put it on the x-axis here. Okay? Now, remember how I said tangent goes up on the left? Tangent goes up on the right? At pi over 4, we're going to go up 1. Why 1? Because the coefficient of the tangent is 1 over there. Okay? And then to the left, I'm going to go down 1. It's going to be symmetric. And then I graph like this. And that's how it looks. Now, for the tangent ones, I'm actually going to not recommend, I'm not going to recommend that we skip, boxes. So for the next one, I'm just going to do it without skipping any spaces. Cooper?
So here, I just want to clarify the 2 points at the end, which is negative pi over 2 and pi over 2. Those are always going to be asymptotes.
Yes, always.
And then you only need 3 points. You don't need 5 anymore.
Well, yeah, 5.
I mean,
right. Yep, exactly. Yep.
And then the amplitude is the coefficient in front of tangent.
Correct. We don't call it amplitude, but yeah, I see what you're saying. Okay, so let's take a look at this next one. Now it's 3 tangent of x. So the 3 in the front is what's changed. But nothing else has changed. So I'm going to start with negative pi over 2 again. And then without skipping boxes this time, 1, 2, 3, 4 to pi over 2. And I have 0 in the middle, negative pi over 4, positive pi over 4. Okay, I put in my asymptotes. Next, The center point is going to go on the axis because there is no vertical shift. Now, the other points, you see how there is a 3 in front? That means to the right, instead of going up 1, I'm going to go up 3. And that means to the left, I go down 3. It's got to be symmetric. Here's the thing now. What happens here is that curve that we had here, imagine grabbing that green line from both ends and just stretching it up. So rather than adding curves to this, you're gonna make the curves go away. So it's gonna get a little bit flatter. And the way we draw it is this, okay? Sometimes you wanna add some curves in there. So I get, graphs that look like this, but this is a tangent graph. This is not a pretty waterfall. So we're not gonna add artificial curves to this, okay? All right. The next one, let's do that super quickly. Now we have -2 tangent x. So again, we start from -π/2 to π/2, 0, -π/4, π/4. I put in my asymptotes. Okay, now put the center point where it belongs. Okay, now I have a -2 here, right? Negative means reflection. So here there is a reflection because of that negative. That means to the right, instead of going up 2, I'm going to go down 2. And then to the left, I'm going to go up 2. And I graph like this. Okay? Questions? Shatsainga. Okay. Okay, so let's do this next one. Here I have tangent of 3x. So the period has now changed. What I do is I go from -π/2 to π/2, but I put in the 3x. So I'm going to divide by 3. Dividing by 3 means multiplying by 1/3. Okay, so it goes in the denominator. So I have -π/6 x π/6. That is your graphing region. Also, these are your asymptotes. So when I'm asked for the asymptotes, I say x equals -π/6 and x equals +π/6. Asymptotes are lines, so you have to have x equals. You can't just do π/6. Okay, let's graph this guy. I'm gonna go from -π/6, 1, 2, 3, 4 to π/6. Okay, in the middle it's 0. That other point in the green is halfway from 0 to π/6. That's half of π/6, π/12. And the other one is -π/12. Okay, let's put in the asymptotes. The rest is history. center point on the x-axis, there is a 1 in front of the tangent, so I go up 1, down 1, and I get my tangent. Okay? Questions? All right. Next, I have 1 over 3x in this one. I'm going to bound it between negative pi over 2 to pi over 2. The fact that we had all that practice with sine and cosine, right now we got the system down, and it's just the values that are different. In this case, I'm going to multiply everything by 3. So I'm going to go from negative 3 pi over 2 to 3 pi over 2. That means asymptotes are at negative 3 pi over 2 and 3 pi over 2. Okay. I'm going to go here from negative 3 pi over 2, 1, 2, 3, 4 to 3 pi over 2. Asymptote, asymptote. Center point is 0, right? When it's symmetric, and the center point is always 0. And then the other points are negative 3 pi over 4 and 3 pi over 4. And then the rest is the same, so 0, 1, negative 1, boom. Okay. Last but not least, now I have a phase shift. So things are going to change a little bit more. I take my x plus pi over 2 and I put it between negative pi over 2 and pi over 2. Now, if I have x plus pi over 2, I'm going to subtract pi over 2 from everywhere. And what I'm going to get is negative pi x 0. Maddie?
How did you get pi for negative pi over 2 minus?
Because what I had was negative pi over, let me write it like this, minus pi over 2. Right? So the denominator is 2. And then I have negative pi minus pi, that's negative 2 pi. Yeah. Also, I say half pi, another half pi is 1 pi, but negative.
Okay.
Yeah. So asymptotes are at x equals negative pi and x equals 0. Okay. So negative pi, 1, 2, 3, 4, 0. Okay, let's do the midpoint. Halfway from 0 to negative pi is negative pi over 2. Yeah, Cooper?
Negative pi over 2. Oh, you mean...
Oh, I thought you had a question. I'm sorry. Halfway from 0 to negative pi over 2 is negative pi over 4. Then what about that green one? So that's halfway from negative pi to negative pi over 2. Right? So that's halfway of negative 3 pi over 2. So negative 3 pi over 4. So that's negative 3 pi over 4. Okay, let's put in asymptotes. 1, 2. Okay, center point goes here. Now look, I have a negative tangent of x plus pi over 2. So to the right, I go down 1, then up 1, and I graph this way. Okay? All right, questions? Yes, no? All right, if you have questions, I'll take questions. If you don't have questions, go ahead and scan and you can upload into MyJag. It says